All right, so we are talking about scatter plots and lines of best fit. So a lot of this is just going to be definitions in the beginning, okay? And remembering a couple of things. So let's talk about linear equations that model real life relationships. So I want you to read this first one, read this one, and I want you to try to write an equation. So this stems back to 4.4, okay? So reading this and writing an equation based off of that. So take a moment and think about that. So I want to identify important information first. So I know it's $45 per hour. Okay, they make $45 per hour, so that's important. He also charges a $100 setup fee. Okay, so where Y is the total charges and X is the hours. So I know that our total charges are equal to the $45 he spends per hour plus the $100 setup fee that we get charged no matter how many hours he's there. Okay, so since we kind of went over the first one, try the second one. So pause and try this. Okay, so hopefully you got y equals 27 minus 5x or y equals negative 5x plus 27. Either one, okay? They both do say the same thing, just one starts with how much the fish originally weighed, so it doesn't really matter. My question is, what is necessary for a relationship to be linear? What does it mean to be a linear relationship? Hopefully you said a straight line. Linear relationships make a straight line. And they are dependent, right? Our y is dependent upon our x. So they are dependent as well. Okay, so it makes a straight line, which means they're correlated exactly for each well. But real life data does not always fall neatly, okay? Such as hours spent studying, distance in miles, year and average yearly consumption of bottled water, okay? To really show real life data, we use something called a scatter plot, okay? And a scatter plot's a graph that shows the relationship between two variables. So it shows the relationship between two variables. Okay? Why is that not working? So it shows our relationship. It can determine if there is a relationship or really a pattern. So we're really trying to figure out, we graph this information and figure out if there's a pattern. And that pattern is actually called a correlation. So that's the technical term, okay? A correlation between the two. And there's three different correlations. There's positive correlation, which is this one right here, this first one, a positive correlation. And it's positive because if you look at this line, if you look at these dots, they kind of make an upward trend. Okay, there's a negative correlation because if you look at these, you're looking for a pattern, they kind of all go down, right? And then the last one, no correlation, because there's no set information on the data, okay? There's no true up or down, or there's also something called a cluster, which if there was many points right here, so let me do those in black so it makes is a little bit more obvious. So if there was more dots right here than anywhere else, see how if you look at this now, there's more dots in this area than there is anywhere else. Okay, so that would be a cluster because there's more points clustered together than there is out there. So this would be called a cluster. But ultimately, it's still no correlation because all of these points don't really make anything. Okay, so let's look at actually doing this. Okay, so we are given the following information. Now, before we do anything with that information, we have to create our graph. So whenever we make a graph, normally we give it a title, but I'm not so focused on giving it a title because I don't really care, to be honest. But we do need to label our X and Y axes. We do need to label our X and Y axes. Remember, a table goes X, Y. Okay. So that means your X is down here and our Y is here. So we're going to label down here, days absent. Days absent. Well, I'm going to shrink this a little bit. Let's shrink it so we can see everything. Days absent. Days absent. And this is your exam score. Okay, so now that we've done that, now we need to set a scale up. So how do we want to put the numbers down here on this graph? What do we want our graph increasing by via the X? So I know I always start at 0 on my graph, and I see that I have to go from 1 to 20. But if I count these, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I only have 14 lines here. So I know I can't count by ones. So I'll probably count by twos then. So let's start by doing 2, 4, count by twos. Okay, I'm just going to stop at 20 because that's where our information ends. Maybe not. 22. Let's just go all the way. 26, 28. Okay, now, looking at your exam scores, they're pretty high numbers. And again, we only have 14 spaces to go. So what I'm going to do is on your graph, there's a little thing that you do this. It's like a little M, and it shows that you're jumping. So if you make a big jump in your data numbers, that's what you would put. Okay, and I'm going to do that because the lowest number I have is 45. So that's probably where I'm going to start my graph, is at 45. And then I have to go all the way up to 90. So, and there's a lot of 50, there's a lot of numbers that end in 0 or 5. So I'm going to count by 5s. So 50, so count by 5s and start numbering your graph. So this is the tricky part about scatter plots because they are so unique, because you may be thinking, but I don't want to count by 5s. Well, you don't have to. That's just a suggestion, and it's a little helpful. You could have counted by 3s, I'm sure, or 7s, or 10s would have been too close together, so I probably wouldn't have done that. And I don't think 2s would have fit, but it's really a personal choice. So is finding the line of best fit, which we're going to get to soon. But let's first now, we can start graphing these ordered pairs. Okay, so start graphing those. So we go to 1 and 90. We go to 2 and 97. I don't have a 97, so I'm going to go close. 3 and 87. That's in the middle. 3 and 91. So it's okay to have 2 dots on the same, bar, because that's what happens. 70. So we're just graphing these points as we come across them. 12, 55, 16, 51, 20, and 45. Okay, so we graph those. And then we have to figure out, is there a correlation? Do you see a correlation happening? Hopefully you said yes. And is it a positive, so is it going up? Or is it coming down for a negative? It's a negative correlation. Why do you think that is? Think about our data. Why do you think there's a negative correlation? Okay, so think about when you miss school. What happens? Right? When you're absent, you don't learn all of the content. Okay, so now we have our scatter plot. Now we have to draw a line of best fit. A line of best fit, which is the whole point of this, is a line on the scatter plot to best estimate the relationship between the two variables. Or it's also can be called a trend line. Okay, so what we're first going to do is draw a line of best fit. So I would say I always try to get at least 3 points of my data on the line. Okay, so I always try to get as many points as possible, but I try to get at least 3 points of data on the line. Okay, so we're going to draw a line of best fit here. So I might maybe get a ruler. That might be helpful. Maybe get a ruler. I can't really do that, so I'm going to eyeball it. So I want to get as many points as possible. So I think to do that, starting at 95 might be good. Going through this point and this point, and maybe one of these. And so I got 1, 2, 3 on the line. Okay, so it's not going to be possible to get all of them on the line. It's okay if you have some above and some below. We're just trying to get a good estimate of the trend, okay? So it's okay if some are below, some are above, all those things. Real quick side noting, if I had a point that was like way out here, what would this be called? Does anybody remember? It'd be called an outlier. I just figured I just remembered that, so I wanted to throw that out there. Okay, so we have our line of best fit. So we have to write the equation of the line. So I can't really figure out that slope. And I know my b value is where it crosses my y-axis. So let's look, where does it cross my y-axis at? Here at 95. So I know my y-intercept or my b value is 95. And I'm going to find a point. I'm actually going to write 2 points that I have on the line. Okay, so I'll probably use, I like the points that are on dots exactly because it makes it a little simpler to see them. But I would also just double check. So I'm using 8 and 60 and 16 and 51 as my 2 points. But my line also went through 3 and 87. So you could use any 2 of the 3, but for this case, I'm doing 8 and 60 and 16 and 51. So I'm doing 8 and 60 and 16 and 51. Okay, so let's find our line of best fit. So remember how we find our slope. We do y2 minus y1, x2 minus x1. So I get 9 over 8, and it's negative. And our slopes aren't going to be pretty, okay? They're not going to be pretty slopes. And if you drew a different line of best fit than me, then your slope's going to be different, okay? So that's really the hard part of this is there are some right answers, but it's an estimation, so it's open to interpretation. So as long as you back up your information with data, such as showing me your slope or telling me what points you use, then I'll be able to make sure you're doing it correctly. Now we simply write the equation, okay? So my equation is going to be y equals negative 9/8 x plus 95. Okay? So then the last part is predict the exam score if a student is absent 10 days. So I want you to try to do that. Okay? I might either, two things, either plug it in for x up here or look at the graph. Either one, but you'll get more exact information by plugging it in. Okay.